All right, hi everybody, welcome back. Today we're going to talk about antiderivatives, kind of the second half of calculus class. And I was actually just talking with a student, and they had done so much work with derivatives. They thought they're really getting it, and they were. I mean, derivatives are hard, and it's a lot of work. But after hearing that there's something called antiderivatives, I think it was kind of a daunting thing to hear. But I'm here to tell you that it's actually not that bad. There's less rules. There's no like quotient rule or product rule, but there is a lot with integrals. But I just wanted to do this first video to just kind of give you a general idea of what an antiderivative is. You're going to see the word integral and antiderivative used interchangeably. Let's type it out. So make a little text box here. Oops. Integrals equals antiderivative. It's the same thing. All right. So kind of looks like a musical symbol. And it's like, let's just say this is our function is x. One second, let me turn off my name thing. And then at the end of it, they have dx. So what that means is with respect to x. So an integral symbol is this, and it always ends with d, like with respect to whatever variable we're talking about. So let's just say it was the integral of m. That's the same, just a different letter. It would be with respect to m, like taking the integral over m. So let's do x because it's easier to get used to. Well, if we remember, if our original function was like x squared, right? Well, what was the derivative of that? You take the 2, put it out in front, and then you take 1 away from the 2, so that would just be 2x. That is taking a derivative. But now we're going backwards. So instead of the, this is x to the 1. Instead of it going down by 1, we're going to add 1. So it would be x squared. And then whatever the coefficient was, in this case it was a 1, we put that new number, the new exponent, below it. So sometimes it's written like 1 over n plus 1 times x to the n plus 1. If the integral of x to the n is equal to, you add 1 to it, and that's 1 over that new exponent. That, a lot of times students will see that in that form. It's kind of confusing, but so I like to just show examples. So let's do another one. What if it's the square root of x? Or even better, what if it's the cubed root of x dx? Always rewrite your square roots as an exponent as a fraction. So the square root of x is actually x to the 1/3. Okay, so let's follow the same rules. Let me change colors. Okay, we're going to add 1. Well, what's 1/3 plus 3/3? That's 4/3. So that's our new exponent. And then it's 1 over that new exponent. So really, 1 over a fraction, we're going to flip it. So it'll be 3/4 x to the 4/3. And I've always thought this is cool about math. You can check your answer. We can take checking it. So we took an integral. So we have a function, and we went up a level to the integral. Well, we can take the derivative and go back. So if this is our function, 3/4 x to the 4/3, what if we took the derivative of that? Well, what's 4/3 times 3/4? They're opposite fractions. That's just 1. And then we'll take 1 away, or take 3/3 away from 4/3. That would be 1/3. And that's just the cubed root of x. So we got back to where we started. let's just do one more here. What if it is the integral of 5x to the third plus the cubed root of x squared plus 1, okay, with respect to x. So every part is separated by a plus or a minus. So actually, let's make this a minus just to make things fun. Every part is separated by a plus or minus, so just like in a derivative, you do it in separate parts. So let's add 1 to this. That would be x to the fourth, and it would be 5 over that new number. And then let's rewrite this as, well, what is x squared? The cubed root means to the 1/3, so it's x to the 2/3. What if we add 1 to that? So 5/3, and it's going to be 1 over, so 1 over 5/3 would be 3/5. Then here's where it's interesting. This is kind of like x to the 0. So it would be x to the 1 if we add 1, and it's 1 over 1. So just 1x to the 1. And the minus sign, does that go away? Well, no, because there's no other minus, so it just stays as minus. This is going to be our integral, and we can check by taking the derivative. 4 times 5/4 is just 5x, and we're going to take 1 away to the third. And then 5/3 times 3/5 is just 1. And we're going to take 3/3 away. So that would be 2/3, which is how we have it up top. And then 1 times 1 is just 1, or 1 times -1. And we're going to take 1 away. So actually that just goes away. So we're back to where we started. 5x to the third plus the cubed root of x squared minus 1. All right. I'm sure we'll get a lot more integral practice, but for the time being, that's just a little intro. And always know you can submit questions to info@lifesavingtutors.com, and we'll see you next time.